So let's take a look at pseudocode. So this is uh, our daily routine in like our online classes, with waking up, getting a shower, eating breakfast, powering on your computer, and starting Google Meet, and so on. So if we write this in code, we can write this in code, but it will not make any sense. So pseudocode basically means false code. Okay. So pseudocode is basically false code. The word pseudo means false. Okay. So hence pseudocode means false code. So we can think of pseudocode as our logic of the program in plain English. Okay. So in this class, we are going to take a look at the pseudocode of each topic, and then I'm going to show you that. See. Okay. So let's take a look at control flow. In the last class, we take a look at how to print data, how to take in data. So in this time, we are going to take a look at how to control the flow of data. So for example, if if the weather is rainy, we take a raincoat. If the weather is sunny, we don't take a raincoat. And if there is a massive thunderstorm, we stay inside. So we are controlling the flow of data. So for example, if a variable rainy is true, we take a raincoat. If a variable sunny is true, we don't take a raincoat. And if a variable thunderstorm is true, we stay inside. Okay. So we are going to take a look at that in C. So we can do like this: new terminal, and we're just going to presentation mode. So if you recall, we have to do cd text path like this, then cd L01. I created a new directory, and then I can make a file using touch. Then I will make a file named boat.c. So as we know, people who are above 18 can vote, and people who are below 18 cannot vote. So this is basically common knowledge. So we are going to recreate this in C. We are going to open this file, and we are going to write the boilerplate code that we talked about last time, which is include stdio.h. It is stdio, not studio. Okay. Stdio stands for standard io.h. And then I can write int main void. Okay. Void. And then I can create a variable age, and I can take the value of that using get int. Now the getin function is in the CS50 library, so I have to include that too by writing include cs50.h. So I can use the getInt function now. I can write enter your age like this, and then I can write if and parentheses open and close. So in this we have to write a condition. I can write if 18 is smaller than or equal to the age, then I can print you are allowed to vote, then \n for the new line, or I can write else print if you are not allowed to vote. So let's take a look at this code again. So we are including the CS50 library for the getin function. We are including stdio.h, which is standard input output.h, for the printf function. Then we are declaring the function main. We are going to learn about functions in this class too. So we are declaring the function main here, and inside it we are we are declaring a variable age, and we are taking the user input for that. And then let's take a look at these two new lines. Okay. So I am writing if. So what does if mean? If the condition inside the if block is true, then the code inside it is going to run. Okay. And if this condition is not true, then this statement is going to run. Okay. So I can just compile this program. I can hit make vote. Okay. So I didn't put a semicolon. Just a minute. Right. Make vote. This program compiled. I can write dot slash vote executed. Then I can write enter your age. So I can write 15. You are not allowed to vote. Then I can execute this program again. I can write, for example, 56. You are allowed to vote. And if I write 4, you're not allowed to vote. So this if block, what this basically does is, if this condition is true, this code will be executed, and this else block, this code will not be run. Okay, this code will not be executed. So to explain this a bit more, I'm going to make some changes. I can write touch pass fail dot c. Okay, so this is a better example for understanding conditionals. I can just clear the terminal, and then for pass fail. So in this program, we are going to create a limit. Okay, so if the marks of a user are above a certain point, then the user has passed, else the user has failed. Okay, so I'm going to include cs50.h for getInt, standard io.h for printf. I'm going to declare my main function, main void, and then I'm going to write int. This is a variable score, and we are going to get its value using getInt. Enter your score. Then a semicolon to end the statement, and then I can write this: if score is greater than or equal to 90, I can write printf you passed with honors. So honors, we can honors basically means like an extra criteria of pass. You can get like a prize or something for it. And then I can write else. So okay, we took a look at the else statement, but there is one more statement in the conditional, which is else if. So if this statement is false, then this condition is going to run. Okay, so if your score is greater than or equal to 60, then it is going to print you pass. You pass. And then I can write else printf you failed backslash n. I can compile it, make pass fail dot c. Okay, not c, it is just pass fail. Make pass fail and dot slash pass fail. I can I can write my score as 90. Then I passed with honors. I can execute it once more. Then I can write 4. I failed. So one more thing, the difference between the if and the else if statement is, if this if condition is true, then these two blocks of code will not be executed. So this, if this condition is true, this condition will not be checked. Okay, if this condition is true, this condition will not be checked. So if I just write if here, I can just compile the program again. Just clear it. Let's make the screen a little bigger. Clear. Can I make pass fail dot slash pass fail. So if I write, for example, 91, can anyone predict the output? So the output is different from last time. It is you passed with honors and also you pass. The reason for that is I am putting two if statements instead of an else if. So if I consider this is a single block of code, okay? If there is an else statement too. So if this if statement is true, then these two will be not be executed. So this condition will not be checked. If I just write if here, then doesn't matter if this condition is true or false. This condition will always be checked. Okay. So this is basically conditionals. So these were conditionals. So conditionals are basically written to control the flow of data. Okay. And so now we are going to take a look at one more important concepts, which are loops. So many times, so I am going to take an example. If I want to print numbers from 1 to 100, I can add something like this: print 1, print 2, print 3, print 4, and so on. So one can imagine that this will take a lot of time, right? So instead of this, I can in pseudocode, okay, again in pseudocode, I can write something like this. Let a number be initialized to 0 while number is smaller than 100. I will print the number and then add 1 to now and add 1 to the number, okay? So this basically means like I am going to start with 0, okay? Then while number is smaller than 100, okay? So 0 is smaller than 100. Then I'm going to print the number. So means 0 is going to be printed and then I'm going to add 1 to the number. So the value of number is now 1. Then I'm going to check this again while number is smaller than 100. Yes, 1 is smaller than 100. Then I'm going to print 1, add 1. So 2 is smaller than 100, print 3, and so on, so on, so on. Okay. So this in C is known as a while statement. So I am going to recreate the same program in C. I'm just going to close this window and I'm going to write touch print 101 dot C. And this, then the boilerplate code include stdio.h int main void. Then I'm going to initialize the number to 0. As I wrote in pseudocode, I'm going to initialize the number to 0. And then again, as I wrote in pseudocode, I'm going to write while number is greater than or equal to 100. So writing equals to is important, okay? If we don't write the equals to, it is only going to print a 99. So writing equals to is pretty important. I'm going to demonstrate it too. Then I can write printf percentage I as an integer placeholder, new line, and then num, which is the variable we defined. Okay. Then I'm going to increase the value of the number by 1. So this is the assignment operator. Okay. So this is the equals to sign, but in programming, this is known as the assignment operator. So like in mathematics, no number can be equals to like its successor. Okay. Like 2 can't be equal to 3. So what does this assignment operator means is like it goes from right to left. Okay. So num plus 1 is now the new value of num. Okay. So if I execute it, I can go to file, new terminal, terminal here. I can write cd and cd again l1 make print 100 dash 1 dot slash print 100 1. So as we can see, numbers from 0 to 100 are printed. Okay. So as I said earlier, if I only write is 100 greater and not the equals to, I can write it again, make this, then execute it. As you can see, only the numbers till 99 are printed. Okay, so the last condition is not checked, like is the number also equal to 100? Okay, so the last number that is checked is 99. So there is one more way of doing this even faster. Okay, so as we can see, there is 1, 2, 3, 4, 5, 6 lines of code in this. Okay, so I can do this even faster. I will just clear the screen, then touch print 102. Okay, not print 100 to print 102.c. I'll just read the file. So there is a faster way to do this. So I will write the boilerplate code again. So if I write for, so this is not going to make sense. Okay, in the first try it is not going to make sense, but trust me, it will make sense in just a little bit. Okay, so I forgot to tell you one thing. This statement num is equal to num plus 1 is used so many times in programming that computer scientists found a way to shorten it. So this is known as syntactic sugar basically. So this, okay, there is something known as a comment. If I do double backslash, okay, so this line is completely ignored by the compiler right now. I can write num plus plus. Okay, so num plus plus and num is equal to num plus 1 means the same thing. Okay, so I just basically shortened the line. There is no logical difference in the code, but the code looks a lot more clearer right now. Okay, I will just, I can just compile it again to show it to you. Make print, okay, make print 101 dot slash print 101. Then it is printed till 99. I can just add an equals to here if I wanted to print it to 100. I can just compile it again. Then it is printed till 100. Okay. So shortening a line of code is basically can be there is a term for that known as syntactic sugar. Okay. So now let's take a look at this line of code. So this is the for statement. Okay. So this is the for statement and there is a function. So and this function takes three input basically. So this statement has three inputs. There is a variable initialization, there is a condition, and there is what okay, there is a statement which classifies what will happen to the variable after this condition is true. Okay, so what does this code basically mean? I will start with the variable I which has a value of 0. Okay, and then I will check is the value of I smaller than or equal to 100. Then this code will be executed. Okay, and when this code is executed, this third statement will be executed. So I can write this in comment. So if I just copy it, I can write this, then write this. Okay, so this all is in comments. Now like the value of I is 0, then I can write like this: 0 is 0 greater smaller than or equal to 100. Yes, 0 is smaller than or equal to 100. Then 0 is printed. Okay, and then the value of I is increased by 1. Then is 1 smaller than or equal to 100? Yes, 1 is smaller than or equal to 100. Then again 1 is printed. So like this. Okay, this will take some time to sink in. But if you like play around with the for statement, it really helps a lot. Okay. So there is also a third kind of loop. It is not. Okay, so I think I've not executed it. I will just wait dot slash print 100 dot. Then okay, so this basically does the same thing. Okay, there is also a third kind of loop known as a do while loop. Okay, and I print 100 dash 3 dot c. So the do while loop is used only in special cases. Okay, but I'm going to show you in this case too. Standard io.h. Now while num 100. Now I will just execute it to show if this is working. I will explain it just not slash print 100 dash. So as we can see, this is working. So I can just open these two files side by side, this print 100, okay, like this, okay. So the only difference between the while and the do while loop is in a while loop the condition is checked. If the condition is true, and then the code inside it will be executed. But in a do loop, in a do while loop, the code is executed and then the condition is checked. If the condition is true, so like if the condition is true, then the code will be executed again. It will be executed again. So these two are basically do the same. So these two basically do the same thing. But in a do while loop, the code is executed once before the condition is checked again. But in a while loop, the condition is checked and then the code is executed. So to make sense of it, the do while loop, I'm going to use a better example for it. Yes. Okay. So I'm going to make a new file named touch vote2.c. Okay. So new file is created. I'm just going to open vote2 also here. Okay. So let's execute vote2. So let's execute vote. So if I write my age is 76, for example, yes, I can vote. If my age is 17, no, I cannot vote. But there is a small bug in that. So the difference between a bug and the error is if there is an error in a program, your program will not compile, it will not run. But if there is a bug in a program, the program may run. Okay, so there is not a 100% probability. The program may run, but there will surely be a logical error in a program, logical or any other error in a program. So if I write -8, like age is always age is always a whole number, right? It goes from 0, 1, 2, 3, 4, 5, 6. There are no negative numbers. Okay, so it says -8, you are not allowed to vote. There is no age known as -8. Okay, so I can use a smart trick to make it okay. I can use a do while loop in it. Okay, so the do while loops are pretty useful in these kind of scenarios. I can write do while like this, then like this. I can write while 0 age. So what does this statement do? So I've initialized a variable age and then I'm taking the user input for to fill in the value, to fill in the variable. Okay. So if a user enters a value which is smaller than 0, the condition is the condition is written here. If age is smaller than 0, then this loop and then this code will be executed again and again and again. I can show it like this: print vote. Okay, so I think I did it in vote.c, doesn't matter. So if I execute make vote dot slash vote dot slash vote, if I can write, I can add -9. This is asking the value again. This is asking to input the value again, to give the value again, because the statement inside it is true. So the loop will be executed. Okay. If I write a negative number again and again and again, so this will continue on as long as as long as I give it a negative number. As soon as I write a positive number, the program will stop automatically. So there is one more example for this. You can write touch pass fail 2.c here, pass fail 2. I can open it here. Okay, so I'm just going to copy the code here into the new file. Then our goal is to make the input correct again. Okay. So they might be wondering out why I am not doing it like this. Okay. So I am not initializing the variable inside the loop. Okay. So this may work, but the problem in it is like the actual variable, the actual memory is like is created again, deleted again, created, deleted again and again and again. So that is not good. So that's why we initialize the variable outside the do loop. Okay. And then we take in the value inside the do loop. Okay. Then I can write a while statement here. I can write while. So for example, this in the numbers in this list can't be in negative or more than 100. So to write it in like in C, I can write score 2 bars 100 score. So this means if the score is smaller than 0, or so if I write these 2 bars, okay, so these are special characters. So this basically means or. Okay, this means like or. I cannot write or, but I have to write this. So this statement means while the score is smaller than 0 or your score is greater than 100, it will ask you to it will ask you to input the number again and again and again and again. I can execute it. Right. Okay, I really need to stop closing the terminal. Like it takes an ample amount of time to change the direction. cd 01 make pass fail 2 dot slash pass fail 2. If I write a negative number 9, it is asking again. If I write a number which is greater than 0,000, it will ask again. If I write 101 -1, but as soon as I write 91, for example, it will say you passed with honors. I can write -17, then I can write 60, you passed, like this. Okay. Now we are going to discuss functions. So many times in our code, uh, like many statements are repeated again and again and again and again. Okay. So there is an unspoken rule of programming known as DRY. Okay. So what does DRY stand for? DRY is an acronym standing for do not repeat yourself. Don't repeat yourself. Okay. So the code you write shouldn't be repeated again and again. For example, this. Whenever I start a class, I take these 5 steps: make a meeting link, send the meeting link, admit the people, start the class, and then end the meeting. Okay. So like If I write this in code, like I have to write 5 statements inside a if statement again and again and again and again. So I can do something like this: function, class. Okay. So in a single function, I have inserted this 5 statements. For example, this: if the class is 8 June, I can just execute this function which has these 5 statements. So instead of writing these five statements 2 times, I can just write the name of the function class. So executing the function is known as calling the function, and writing the function like this, I've written the function in pseudocode. It is known as declaring the function. Okay. So the concept of functions, like we have used functions till now. For example, like getInt is a function, and then printf is a function. But we have not declared custom functions till now, like, or user declared functions. Okay. So we are going to do that. So like this, I can create a new file, touch average.c. So I'm going to print the average of 3 numbers in it. Okay. stdio. Okay, so I can declare 4 variables now, like int score1 equal to 25, int score2 equal to 50, int score3 equal to 75, and then int score4 equal to 100. Okay, so for those of you who don't know what average is, basically add all the value and divide it by the number of values. Okay, so if I want to print the average of it, I can hit printf, then a percentage I, which is an integer placeholder, percentage I, new line, and then I can write this. I can add score1 plus score2 plus score3 plus score4. Then I can divide it by 4. Okay, I can write make average. So what is the problem? Okay, I missed the semicolon. I can add make average is executed. I can add dot slash average. The average is 62. Okay, so like if you want to calculate it on a pen and paper, you can basically add 25, 50, 75, and 100, and then divide it by 4. Okay, like this is basically what average is. So this line of code is pretty big, right? We do not want to, like, if I want to take an average of 4 more numbers, for like int score 5 equal to this number, then int score 6 equal to this number, int score 7 equals to this number, and then if I want to take the average again, I have to divide it by 3 first, and then I can add int score 5, score 6, score 7. So as we can see, like, the logic of this statement is same, right? We are adding all the numbers and dividing it by the addition of the 4 numbers. No, yes. And then in this statement, okay, we're adding the 3 numbers and then dividing it by 3. Okay, so a better way to do this is like writing a function which takes in the average. Okay, so as we have written in this int main void, so this is a function, int main void. So the name of the function is main. The value it returns is an integer type, and the value it takes in as an input is void. Void means it takes nothing. So ignore the main function. This is how we write, you can see. So if I want to create a function named average, I have to write int, because the average function will always return an int. Like the average of a value is always an integer, right? So if I calculate the average of 3 numbers, that will also be an int. So I always return an integer from the average function. The name of the function will be average. Okay. And then this is the important part. I have to take an input three numbers. Okay. So in this function, I will take the average of three numbers and return it to the user. I can take like int num1, int num2, just a minute, int num2, int num3, this return. I can write like this: num1 plus num2 plus num3 divided by 3. So if I do like this, I can create a function abg. This is a variable. I can write average here. Then I can write like this: score 1, score 2, the score 3. So this function only takes in three numbers. Okay, so I cannot write score 4 here. It will give out an error. Okay, so if I write like this score 4, an error is generated here. I can only take in three numbers like this. Okay, so there is a problem in this code. I am calling a function before it is declared. Okay, so the function is declared on line 11, but I'm calling it on like line 8. So one thing that I can do is can write it like this. But the problem with this way is like I can declare many functions. Like if I declare 100 functions in a program, the main function where or most of the code resides, or master code or the main code resides, keeps going down. So like that is not good. A main program is always resides in the main function. Okay. So to overcome that, we use a thing known as a system, known as a function prototype. Okay. So if I want to use it like this, this doesn't make any sense, but this is how C works. Okay. So what this line is basically doing is it is saying to the compiler, there is a function which exists somewhere in the code with the value, with the name of average, its output value as an int, and then which takes an input num1 2 3. Okay. And then the function is declared here. Okay. So the compiler does its work and find the function so we can use it. So like again, a small recap. Now why is the why do we write int at starting? So int is the output, the data type of the return value. Okay, so when I add num1, num2, num3 and divide it by 3, so the answer may be in a decimal, but it is automatically converted into an integer. So the data type of this statement, is an integer. So the value that is returned from the function is an integer. Okay, that is why we write int. I take in a number 1, 2, 3, add it, and then divide it by 3. So I can execute it to show it to you. Make average dot slash average. So am I writing it correctly? I cannot see. Dot slash average. Okay, so I forgot to print the value. I can write this printf percentage I backslash n. I can write in avg. So this is the average value. I will write this. There is some problem in the code. Average. Okay. I have not compiled the code again. This is a rookie mistake. Average. So the what do we say? The average of these numbers is 50. So the return statement basically means if I write a function like this, it is returning the output of this function to this variable. Okay. So this is what the return statement means. So the functions are one of the most important things in programming. So we're going to take a look at one last thing, okay? So the code for it is pretty big, so I'm just going to copy it. So as we discussed earlier, the last topic for today is scope. Okay. So what does scope mean? Scope, we can define scope as a virtual area in which the value of a particular variable can be used. Okay, so uh, this may be pretty hard to understand. So I will just execute the program. So what does this does? Just a minute. Okay, so this is average. Make average dot slash average. So enter the number of students. I will add 3. Enter score 1. I will add 45, 67, 28. Student 1 passed. 34, 2, 56. Student 2 failed. 67, 45, 90. Student 3 passed. So this is what this program does. Okay. I think we will not use this terminal now. Uh, so there is a function main in this code. Okay, so there is a function average in this code. There is a for loop in this code, and there are two conditional statements in this code. Okay, so if I represent it like this, if I represent it like this, if I represent it graphically, we have, okay, so we have the function main, we have the function average, we have the for loop, and then we have two conditionals here. Okay, so I've created a square for each statement. Okay, so that is what those like you can imagine it as a curly brace. Okay, so this area means where does a curly brace start and where does the curly brace end. So this is the scope of each statement. Okay, the scope of main is the biggest, then for the for loop, and then if and else. Okay, so what does scope actually mean? If I define a variable inside main, okay, if I define a variable inside the main function, then that variable can be used by any statement. Like it can be used inside the for loop, it can be used inside the if statement, it can be used inside the else statement, because all these three statements reside inside the main function. Okay, and then for example, if I declare a variable in the if statement, I cannot use that. I cannot use that variable inside the for loop, for example, because the scope of the for loop is far bigger than the if, than the if statement. Okay, I can like do it like this. For example, the scope of average is totally different than the mean. For example, if I declare a variable in main, in average, I cannot use it inside main. So if I declare a function like int test equal to 420, for example, okay. So if I try to print, if I try to printf percentage I backslash n test, this code is not going to work. Okay, so I did that mistake again. I should not close the terminal. Let's check. Error. Use of undeclared identifier test. Okay. So test is undeclared. Like we have not declared test inside the scope of the function main. Okay. We have declared it inside the scope of the function average. Okay. So the scope is different, as we can see it graphically here. If I declare any, if I declare any, if I, okay, if I declare a function, if I declare a variable in average, I cannot use a main. Okay. So scope is defined as an area in which the value of a variable can be used. So this was the last topic for today. Thank you for now.